Welcome back to section 8.3 for our Algebra 1 topic involving standard form of a quadratic function. We are at the point in our notes where we are doing the steps for graphing quadratic functions in standard form. So as a quick recap here, standard form is, I'm going to write this right next to the little heading, is ax squared plus bx plus c. Okay, so we have the x squared term showing up, we have the x term, and then we have the constant c. Okay, so to graph these things, the first two steps are things we've already talked about within this section. So first of all, we are going to find the axis of symmetry. Okay, and we need to be able to know there's a little bit of a formula that goes along with finding this. And again, we got that in the previous part of our section here. We're using x equals negative b over 2a. Now, again, that negative in front, okay, I like to say opposite of b, just so we know we're doing the opposite sign. So opposite of b over 2a. So once we find that, we actually have found the x of the vertex. Okay, so this is also the x of the vertex. Okay, so since we already know the x of the vertex, we can actually finish out finding our vertex by plugging the x in and finding the y. Okay, so we will go plot that vertex, and then we'll make our table of coordinates. Okay, now we're going to let the vertex be in the middle of our table. That's kind of how we've plotted things already. Our vertex is always shown up in the middle. So the y-intercept, okay, may also be used as one of the points. Okay, so remember the y-intercept is the c. Okay, so out to the side here, I'm going to put 0 for the x, c for the y, and that c is the constant in our function. Okay, so c here all the way up to that. All right, so lastly, as we plot these things, our step 4, once we have our table filled in, we will just sketch the parabola. So remember, our U-shaped graph, okay, is a quadratic, and it's called a parabola. So sketch the parabola. So we're going to go through one of these together, and then the hope is that you will try one on your own here. So let's see how this goes. So we are given the function f of x equals 2x squared minus 4x plus 3. So we're going to find these three items. We're going to fill in our table, and we are going to graph our function. So because we are in standard form, okay, I'm actually going to write my a, b, and c up here. So the a is 2, the b is negative 4, and the c is 3. Okay. So axis of symmetry, remember we find this by doing x equals opposite of the b over 2 times the a. So opposite of the b is actually a positive 4. And we'll do 2 times the a value of 2. So we're going to have 4 over 4, which equals 1. So for our axis of symmetry, remember we want to say x equals, that's an x right there. So x equals 1. Now, we also just found the x of our vertex. So once you know the x of the vertex, remember we just go back and we plug in that x value into our function. So everywhere I see an x, I'm going to let the x be 1. So 2 times 1 squared. Again, I'm plugging into the function. Minus 4 times 1 plus 3. And then we want to follow our order of operations. So exponents first. 4 times 1, or negative 4 times 1 is going to be negative 4. So I kind of did 2 and 1 right there. So we're going to get a value here of, we have 2 minus 4 plus 3. 2 minus 4 plus 3, which is going to give us negative 2 plus 3, which is going to give us a value of 1. Okay, so we just found the y of the vertex. So based on what we said in the top 4 steps there, we're going to put the vertex in the middle. I'm going to put a v for vertex. So here's my value of 1, here's my y of 1, and that's my vertex. So just to kind of fill in the rest of the table there, we're going to go 2 x's smaller and 2x values bigger. Now, the great thing is that y-intercept, when x is 0, which is the c, okay, so remember our c is our y-intercept. So if you look back up at your function, the c value is our 3. So our y-intercept is going to be 0, 3. So since 0 is an x already in our table, I'm going to get my 3 to correspond to the 0. And then by symmetry, because again, since my vertex is in the middle, okay, my vertex is in the middle of my table, okay, we should see a pattern occurring down the y's, okay? So I should end up getting a 3 right there when my x is 2. So let's do this. Let's go ahead and plot this kind of as we're going. Okay, so I've got the vertex at 1, 1, with the y-intercept of 3. Now by symmetry, I'm going to have a point to the right of my 0, 3, the same number of units away from the vertex, okay? So axis of symmetry is here. So I should be able to fold over this line and each side of the parabola land on top of itself, or on top of each other, okay? So I do need to go figure out either x being -1 or x being 3. So I'm going to come down here just right below my graph. I'm going to let x be, let's go with -1 just since it's maybe a little smaller number. I do have to deal with a negative. Okay, f of -1. Because keep in mind, because of our pattern of things, the y value corresponding to -1 and the y value corresponding to 3 should be the same thing. So we're going to have 2 times -1 squared minus 4 times -1 plus 3. Okay, again, by order of operations, I'm going to take care of my powers first. Okay, then I can go ahead and take care of my -4 times my -1 and plus 3. And so this is going to give me a 2 plus 4 plus 3. Okay, so we are actually going to get a little bit off our graph here because that's going to give me a value of 9. So again, because of symmetry, the y value should be 9 for -1, and it should be 9 for when x is 3. So my graph only goes to 7. So there's 8, there's 9. So somewhere right about there and right about there. So keep in mind, we have a little U shape going on here for our parabola. And so once we have our points, we'll go ahead and sketch the parabola. And again, that vertex is that middle point. Okay. And we have completed example 3. Okay. So what I would like you to do here is go ahead and pause the video and try example 4 on your own. You do need a function for this though. So let me write that down for you. Okay. So we're going to go with example 4, f of x equals. And of course, always pause if you need to take your time getting through these notes. But x squared plus 2x plus 4. Okay. You're going to go axis of symmetry, vertex, y-intercept, table, get your graph. When you come back, okay, this example will be done. So please pause the video. Thank you. All right, we are back here. So hopefully you had a moment to get this problem taken care of. There's a little bit of work to it, so it's going to take a little bit of time. Okay, again, to find the axis of symmetry, okay, we used our little -b over 2a. Again, notice that the x of the vertex matches the x of the axis of symmetry. Okay, and then we have our c value, okay, plugging in to be the y-intercept. Okay, so we had to figure out the y of the vertex by plugging -1 in for the x. So again, put that vertex in the middle of your table. Choose 2 x's smaller than -1 and 2 x's bigger than -1. Okay, so once we know that middle value, that vertex, okay, we just need to know to go smaller than that x value and then 2 values bigger than the x of the vertex. Okay, and then the filling in of the table we have practiced already, so hopefully that's going to be going okay for us. All right, so pause if you need to double check things on that one. Okay, we are going to move to the next topic here. Okay, we're going to talk about finding the maximum or minimum value of a quadratic function. Okay, so when they say find a maximum or minimum value, so remember our graphs are going to either open up or they are going to open down. Okay, those are our 2 options. So when a graph opens up, okay, we're going to have a minimum because we have a lowest point. Minimum. That's not very good. Okay, we're going to have a minimum value. Okay, when the graph opens down, we are going to have a maximum. Okay, so what's going to happen here is the maximum or minimum value, okay, of a quadratic function is going to be the y value of the vertex. The y value of the vertex is the maximum or minimum. So when the a is bigger than 0, that's when our parabola opens up. And we just said, so the vertex is at the bottom. So since it's at the bottom, that's when it has a minimum value. Okay? So again, this is the example of things opening up. A being bigger than 0. Okay? When the A is smaller than 0, so A is less than 0. Okay, so now our graph's going to go down. Okay, the parabola opens down. So the vertex is at the top, and therefore the function has a maximum value. Okay, so again, we're going to be talking about the y of the vertex. So example 5 here. Again, pause if you need to, okay, if I'm going too quickly here. Does the function f of x equals, we're going to go with negative 3x squared minus 6x minus 2. Okay, so does the function have a maximum or minimum value? And then we're going to determine the maximum or minimum. So basically, we're going to say it has a max or it has a min, and then we're going to tell what the max or min value is. Okay, so to do this, we have to find the vertex. Okay, so first order of business, we need to think about how this thing opens. Okay, so because there is a negative, okay, in front, okay, this thing is going to open down. Okay, so kind of for question number 1, does it have a maximum or a minimum? We would say it has a maximum value. So has, I'm just going to use max for maximum, has a max value. So now what we want to do is we actually want to find the maximum value. So we need to find the y of the vertex. Before you can find the y of the vertex, you need the x of the vertex. And since our function is in standard form, we have to go use our negative b over 2a to find the x. So in this case, our a is negative 3, the b is negative 6, and the c is negative 2. We are not going to graph these. Okay, so I won't need the c right now. So we need opposite of the b. So the b is negative 6, so I need a positive 6 over 2 times negative 3. So 6 over negative 6, which is a negative 1. Now, that is not my answer. That is the x of my vertex. Okay, we need the y of the vertex. Okay, the y of the vertex is going to be the max. So we know, once we know an x, we plug it in to find the y. So I'm going to now go find f of negative 1. And we're going to plug it in for our x. So negative 3 times negative 1 squared minus 6 times negative 1 minus 2. And then again, apply the order of operations. I'm going to go ahead and do my multiplication here because I already took care of my powers. Oops, that's a minus right there. So minus 2. So negative 3 plus 6, and we are almost to our maximum value. Okay, this is going to be a 3 minus 2, which is going to be a 1. Okay, so our max value is going to be 1. Okay, so it has a max value. We have to tell what the max value is. So the answer to my kind of question number 2 is, we'll just say overall here, max value is 1. Okay, and again, that's the y of the vertex. All right, so we're not graphing these. Okay, we're going to recognize which way the graph opens.
Times add more pages.
We're going to, I'm not sure what that was. We are going to just find
8px, 10px, 12px, 14px, 16px, 18, 20px, 24px, 28px,